Let's take a look at the conditional loops and see. First of all, the while loop. Here's an example where I'm initializing a variable xnum to have the value 2, and we're saying while xnum is less than 5, so while that condition is true, we're going to execute a compound action which is going to increment xnum and print its current value. So xnum starts out at 2. 2 is less than 5, that's true, so we're going to increment xnum to get the value 3, and we're going to print that xnum is 3. We check the condition, 3 is less than 5, so we execute the action and we increment xnum to get the value 4, and we print that out, xnum is 4. Check the condition, 4 is less than 5, so we execute the action, we increment xnum to get the value 5, and we print that, xnum is 5. Now 5 is not less than 5, so that gets us out of the loop and down to whatever comes after that. Here's an example of a while loop in which the action is skipped entirely. So we start a variable xnum at 10. Okay, so we initialize xnum to have the value 10. And we say while xnum is less than 5, we're going to execute an action. Well, okay, 10 is not less than 5, so we don't execute that action at all. Instead, we just go down to the next statement, which prints the end. So again, with the while loop, since the condition is on the top, it's possible that the condition will be false the first time we evaluate it. With the do while, on the other hand, we execute the action before the condition is evaluated. So in this case, xnum is initialized to have the value 10. Then we do, in this case, a compound action. We're going to increment xnum, so xnum gets the value of 11. We're going to print xnum is, and the current value of xnum, which is 11. And then we have the condition that says while xnum is less than 5, well, xnum is not less than 5, so that gets us out of the loop and down to whatever comes after that. But we did execute the action of the loop once because the action is executed before the condition is evaluated with the do while loop. Input in a while loop is a little bit tricky. So here's a problem. What we want to do is we want to repeat the process of prompting the user, reading in an integer, and echo printing that integer until the user enters something that is not an integer. Now a while loop has to be used because we don't know how many times the user is going to do what we ask the user to do. The user may enter a non-integer the first time, in which case the action should be skipped entirely. So we want to use a while loop instead of a do while to accomplish this. So here's what we want the program to do. We want to prompt the user for an integer, and if the user types in an integer, it repeats the process of echo printing that and then prompting again for an integer. So as long as the user is typing in integers, it's going to echo print and prompt the user again for another integer. And that's just going to continue as long as the user is typing in positive integers. As soon as the user types something that's not an integer, for example a string, then we get out of the loop and the program prints OK, and that's it, we're done. Okay, so this is what we want to happen. Now, in order to accomplish this, what we need to know is that the scanf function actually returns a value. So if we want to read in an integer, we would say scanf and then %d to indicate that we want an integer, and then the address of a variable that has been declared to be an integer. For example, it might be called input int. Semicolon, of course, at the end of the statement. So that's how we would read in an integer. Now the scanf function is going to attempt to read an integer because of the %d, an integer. So if there is an integer in the input buffer, then the scanf function will be able to read that into the variable input int. The scanf function returns the number of things that it successfully read in. So if there was an integer in the input buffer and it read it into the variable, then the scanf function returned 1. If there wasn't an integer in the input buffer, so the scanf function could not read it into the variable, the scanf function returns 0. Now do not think of this as being true or false. It isn't. It's the actual number of values. So when we're attempting to read in one thing, either we're going to successfully read in one thing or we successfully read in nothing. So the 1 or 0 is the number of values that the scanf function is successfully able to read in. And if we're trying to read one thing, that's either going to be 1 or 0. Okay, so this is where it's going to start looking a little strange. So we want to keep repeating the action as long as the user's entering an integer, which means as long as the scanf function is returning 1. So we actually embed the scanf function in the condition in our while loop. So our while loop says while the result that we get from this scanf is equal to 1. So if the scanf is successfully able to read into this variable, then the scanf function returns 1. So while the scanf function returns 1, we want to execute the action. So the scanf function is actually reading into the variable. It's attempting to read in the variable. If there is an integer in the input buffer, this scanf function here is actually reading into that variable and then returning 1, so we execute the action. So it's a common mistake to add another scanf in the action. That's not necessary. This scanf that's in the condition is actually reading into the variable as long as there is a valid integer in the input buffer. Okay, so here's what the code is going to look like in the main function. We prompt the user to enter an integer. Then we have the scanf that's attempting to read an integer from the input buffer into the location of the variable input int. While that is able to happen, then it's going to echo print the value of the variable and prompts the user again to enter an integer. So every time we have the prompt printing enter an integer before we attempt the scanf function to read in what the user entered. So as long as the user is putting integers into the input buffer, the scanf function will be able to read those values into the variable, and the scanf function will return 1. As soon as the user types in something that's not an integer, like the word exit, that will return a 0 for the scanf, so this will not be equal to 1, and that will get us down to the next statement in the program, which prints OK. So again, remember that the scanf function returns the number of things that it successfully read in. So it's not true or false, it's the actual number. So let's say we have a scanf that's attempting to read in 2 things. So we want a scanf that is going to read in 2 integers into the locations of 2 integer variables num and val. So in this case, there are 3 possible values that the scanf function would return. 0 if it was not able to read anything in, 1 if it was only able to read into the first variable, or 2 if it was successfully able to read integers into both variables. So if we wanted to keep going as long as this scanf is successful, then we would keep going as long as this scanf is returning 2. So again, the scanf function returns the actual number of values that it successfully is able to read in. So because the user could type in extra things, it's a good idea to flush the input buffer before trying to read something in. So let's say, for example, we have a program, and the program is prompting the user to enter a character, a space, and an integer, and then the user actually types in a character, a space, and an integer. But what's actually in the input buffer there would be the x, the space, the integer 33, and then in order to send that to the input buffer, the user has to hit the return key, and that's going to actually be in the input buffer itself as the new line character. So in the input buffer, we would have the x, the space, the 33, and the new line character. So if we then read into 2 variables, reading into the address of a letter variable, the single character, so that's going to read in the x that was in the input buffer, reading into a number variable will skip over the white space, so it'll skip over that space and read in the 33 into the variable num. So that would be okay. We'd read the x and the 33 into the 2 variables, but the problem is that the new line character would still be in the input buffer. So if we then tried to read in a character, it's going to read in the new line character that's just sitting there in the input buffer. So before reading in a character again, what we'd really like to do is to flush the input buffer to get rid of anything that's in the input buffer, any extra thing the user might enter, or just the new line character itself. So some C compilers have a function that will flush the input buffer. So for example, in at least one case, a C compiler has a function called fflush, stdin, and what that does is that flushes the standard input buffer, which is the input buffer. So the standard in is the standard input buffer. So that statement is going to get rid of anything that happens to be hanging around still in the input buffer. Now, a lot of compilers don't have such a function, and so what we can do is we can use a while loop to just read in one character at a time until we get to the new line character. So get rid of everything extra that the user has typed, including the new line character. Now, to do this, we can use a function called getChar, which just gets the next character from the input buffer. So we can say while, and then take the next character in the input buffer and assign it to a variable, and while that's not equal to the new line character, in this case we want the action of the while loop to be nothing. So as long as we're reading in characters and it's not equal to the new line character, we're just going to keep doing nothing. So that's just going to keep reading one character at a time, doing nothing with them. Sometimes you also need to check for the end of file. So we say while let gets the value of getChar is not equal to the new line. So while we're not at the new line character and we're not at the end of the file. So again, notice that in both cases the action of the while loop is the empty statement or the null statement. We just want to keep moving past the next character until we've gotten rid of everything. So obviously if your compiler has a flush function, that's easier. If not, you can use this kind of a while loop to get rid of all extra characters that might be in the input buffer.